Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together.
This time, I would like to understand from the overview to the communication mechanism related to IP address, which is an Internet communication protocol. I would like to learn how to identify terminals for the Internet that is spreading all over the world. This time, I would like to focus on learning technologies closer to users, such as homes and companies, rather than the content of large-scale networks such as interconnections between operators. This is because there are many experts in large-scale networks, and familiar networks have more opportunities to handle it, so I think it is a common technology. Let's get started. First of all, I would like to proceed in this way as a whole. I would like to understand from the outline of IP address to routing and Ethernet. Now, let's move on to an overview of IP addresses. I would like to understand this kind of content. This is an overview, so I would like to learn as concisely as possible because there is also knowledge content rather than the mechanism of communication. First, let's understand standardization. In order to communicate, it is necessary for the devices to talk to each other using a predetermined technology. Unless you decide how the data is structured, the data is just a string of bits. In conversation, the speaker and the listener cannot understand each other in English and Japanese. Standardization is the agreement on the technology to enable communication in this way. The organization that establishes Internet-related standards is called the IETF, and the standardized regulations are called RFCs. For example, IP4 is specified in RFC 791. Next, let's briefly understand TCP/IP, which is the basis of Internet communication. As I confirmed earlier, TCP/IP is a regulation for communication. IP stands for address on the Internet. This IP represents where the server or terminal is on the Internet. TCP and UDP then deal with port numbers. UDP does not have any particular communication control, but TCP realizes a mechanism to reliably deliver data and to grasp the congestion situation of the transmission line and transmit it efficiently. These TCP algorithms are already up on YouTube. Since it is a useful content as net knowledge, please refer to it from the link in the summary column. Next is the protocol stack. A protocol stack is a rough blueprint for constructing communication data. As shown in this figure. Mainly, Ethernet is the physical and data link layer, IP is the network layer. This figure has two implications. The first is that the rules for handling each layer between the sending and receiving terminals, that is, the protocol must match. The other is that each layer is separate and there is no dependency between each layer. For example, if you use Ethernet for the data link layer, you do not necessarily have to use IP for the network layer, and many protocols such as ICMP can be used. This means that no matter what you use for the data link layer, you can use anything for the network layer regardless. Next, let's check the actual data. You can check the protocol stack. This is a capture of HTTP communication with wire, SHARC. The top window shows one packet per line. The window in the middle shows the result of analyzing one packet. Also, the bottom window has the actual data, and this data is sent in order from the top. Although it is actually one line, it is displayed as one line for every 16 bytes. As you can see, packets are constructed and sent in the order Ethernet, IP, TCP. It is very useful to check the actual communication and packet contents when you do not understand well, such as troubleshooting. Therefore, this time, I also confirmed it with a packet capture. Also, Wireshark, which I am currently using, is free of charge, and you can use it immediately after installing it on your computer. Next, we will understand IP4 and IP6. IP4 uses 32 bits to represent an address, so approximately 430 million items can be identified. However, the world population is about 8 billion. The number of devices connected to the Internet, such as personal computers, smartphones, game consoles, and televisions, is increasing per person, so assigning an IP address to each of these devices would not be enough. IP6 was standardized to solve that IP address exhaustion. Therefore, it is 128-bit. It is possible to give a tremendous number of addresses, 10 to the 32nd power. Basically, the difference between IP4 and IP6 is the number of addresses that can be assigned. Here, I think it's good to understand that there is a difference in the number of bits used for addresses, and the notation method is also different. Next, let's understand the data format. As explained earlier, IP4 has a 32-bit address area and a 20-byte header. The IP6 address is 128-bit and the header is 40 bytes. Headers have both a destination and a source. The destination is necessary to deliver the packet, and the source is necessary because it is the destination to which the other party replies. All packets of data communicated will have this header. There is no technical difference in the IP address itself, so this time I would like to deepen my understanding of IP4, which is widely used today. Next, let's understand IP address types and allocation. We will learn about these items. First of all, about class and CIDR, I would like to know at least the words. As for how to use the IP address, the network part and the host part are used separately.
In that case, classes A, B, and C are assigned from a large-scale network that can provide many terminals, and the length of the network section is determined as 8, 16, and 24.
However, since CIDR is currently used, it is common to express the length of the network part with a subnet mask and add a free length. I think that it is enough to understand that the length of the network part is freely used in the subnet mask. Move on. First of all, IP addresses can be used without problems because they are strictly controlled all over the world and can identify terminals without duplication. This is not technical, but operationally very important. As a management organization, there is IANA on a global level, under which the world is divided into 5 regions, and APNIC is in the Asian region. Under it, there is JAPNIC at the national level, and each ISP receives an IP address from JAPNIC. For reference, about 190 million addresses have been issued to Japan by APNIC, which seems to be around 5% of the total. We end users use IP addresses managed by each ISP, so even if end users arbitrarily assign IP addresses, we cannot communicate and cannot use the internet. If an ISP were to use its IP address on its own, it would be criticized from all over the world and would not be interconnected with other ISPs. An unreliable ISP will not be able to connect and you will not be able to use the internet. For this reason, each ISP strictly manages and operates IP addresses. Due to this mechanism, there is no duplication of IP addresses, and it is operated so that terminals can be identified all over the world. Next, we will understand global IP and private IP. About 190 million IP4 addresses have been issued in Japan, but the population of Japan is about 120 million, and each person uses multiple devices such as smartphones and personal computers. An IP address is also required for building a network. Therefore, it seems that the number of IP addresses you are using is obviously insufficient, but the solution is a private IP address. A global IP address is the only address in the world. Since there is no duplication, it is possible to communicate on the internet that spreads all over the world. A private IP address is an address that is used repeatedly within each home or business. However, private IP addresses also need to be communicated on each network, so they will be unique addresses that do not overlap within the network. If the private IP address overlaps with the global IP address, the internet cannot be used normally. Therefore, the range in which private IP addresses can be used is determined as follows. Now let's understand how it is used. Regarding home use, I think that a broadband router is installed when connecting to the internet. A global IP address for each household is assigned to the broadband router by the ISP. However, I think that home computers and smartphones use IP addresses that start with 192.168. Generally, every household uses the same IP address starting with 192.168. This is because the broadband router converts the source IP address of the communication sent to the internet to a global IP address before sending it, and also converts the destination of the returned packet from the global IP address to a private IP address. Is done. As a result, even if many devices in the home are connected to the internet, they can be operated with a single global IP address. Also, in the internal networks of large companies, terminals do not directly access the internet and communicate via proxy servers. The terminal cannot be accessed directly from the external internet, and communication always goes through a proxy server. Therefore, if the proxy server has a global IP address, it can communicate with the internet. In this way, we allocate a minimum number of global IP addresses and use private IP addresses as much as possible. As a result, even if one person uses many addresses, it can be operated without exhaustion. Now let's understand routing. You will understand things like. Let's continue learning about routing. As shown in this figure, routing is to decide which terminal in the connected network to send to for the destination address. The destination may be the final arrival terminal, but it may also be a relay router. In both cases, you are determining the destination, or next hop terminal, in the connection network. Next, let's understand the subnet mask. A subnet mask is the length of the network portion of an IP address. In other words, it represents the size of the network. As for how it is used, if there is a destination address, it determines which network address matches. If the length of the bit string indicated by the subnet mask is the same, it can be determined that they are the same network. Also, since the default gateway is set with a subnet mask of 0, the length of the network part is 0. In other words, all addresses are applicable to any destination. Next, I would like to understand routing a little more concretely. I actually ran the configuration in this diagram and checked the routing. Since PC1 also relays internet communication for PC2, it also plays the role of a router. Terminals connected to the internet, such as computers and routers, have routing tables, so check the routing table of computer 1. The personal computer's connected network and default gateway are reflected in the routing table and become the route that is mainly used. During communication, the routing table is searched for a destination with the same network address as the destination IP address. Matching is whether the bit strings and the subnet mask match. You can communicate by sending packets to the destination of the found network address, that is, next hop. The destination must be a terminal in the same network that you are connected to, and may be the destination or a relay router. It is called next hop because it is the next destination. Since the default gateway is set with the length of the network part set to 0, all destinations are applicable destinations, that is, all addresses for the internet are applicable. All are applicable, so all unknown destinations are sent to the default gateway. Then, if the terminals on the same link, that is, PC1 to PC2 communicate via the default gateway, that is not the case. Subnet masks, that is, the one with the longer network part, are preferred. We will check this priority. This is the priority for routing decisions. Priority is given to the subnet, that is, the length of the network part. This is called longest match. Therefore, the connected link usually has the longest network length, so it has the highest priority. First of all, I would like to understand this point because it is important here. From now on, if the routing table has the same network address and the same subnet mask, which one should be given priority? It is also used for switching to a sub in a redundant configuration. This is especially important when operating a large-scale network, so let's make a quick query. The second priority is administrative distance. This means that the priority will change depending on the set route type. Directly connected networks have the highest priority, followed by manually configured routes, or static routes. Next is the route obtained by dynamic routing. The third priority is metrics. This is used to set the priority manually or to manipulate the priority of the route by the number of hops or the cost. Now let's move on. Next, let's take a quick look at routing in the internet. The internet is actually a network of interconnected ISPs and business companies. Each operator builds routing by exchanging the network address used by itself with other operators. In other words, I'm using this address, so please send it to me. About it. If you do not notify the other party, it will not be sent and cannot be used. Therefore, each business operator notifies the address they are using so that they can communicate. When notifying the other party, if the route can be summarized, it will be notified as large as possible. By doing this, we are trying to reduce the number of routes that are held each other as much as possible. Still, according to data from 2014, the routing table at the heart of the internet has more than 500,000 routes. It's very simple, but I think it's good to think that it's basically built with this kind of thinking. Next, I would like to understand Ethernet and MAC addresses. Ethernet is a very important technology for using the internet. I would like to learn it because it is indispensable for the mechanism of communication. However, this time we will understand the regulations such as the packetization of the data link layer, not the physical content such as wireless and cable. It means the contents of the place where it works in cooperation with the IP address. The items are as follows. Let's move on to slides. Internet standardization was done by IETF, but Ethernet is done by IEEE. E802.3 is the standardization of wired, and E802.11 is the standardization of wireless Wi-Fi. I'm sure you are using one or the other. As a protocol stack, it consists of the physical layer and the data link layer, and is positioned below the IP address network layer. On the internet, destinations and sources are identified by IP addresses, but Ethernet uses MAC addresses to identify terminals such as destinations and sources. Regarding the specific packet format, as shown here, the destination and source MAC addresses are 6 bytes each in the 14-byte header. It has a very simple format. A MAC address is a 6-byte identifier given to each interface by the manufacturer. With this address, even if multiple terminals are connected in the network, it is possible to identify which terminal it is. In other words, you can think of it as an address that identifies a terminal within a network. Here is a detailed packet capture. You can see that there is an Ethernet header in front of the IP address. All packets are constructed this way. Let's understand how communication works. As you understood in the routing section, routing determined the next destination, the next hop, and obtained the IP address. However, especially in the case of routers, the final destination IP address and the next hop IP address are not the same. Therefore, there is no IP address of the router in the packet header information, so it is not clear that I should receive and process it. Therefore, the terminal is clearly specified by the MAC address of Ethernet and sent. A terminal such as a router that receives a packet can understand that it is addressed to itself from the MAC address. It processes only the packets it should process by MAC address. This role is performed by Ethernet. Also, as explained, the MAC address represents a destination on that network. Therefore, the MAC address of the destination changes when passing through a router. As shown in the figure, the Ethernet header is changed for each network and transmitted to the final destination. In this way, communication is realized by obtaining the destination MAC address from the destination IP address, constructing the Ethernet header, and transmitting it. Next, we will understand when and how the MAC address of the sending party is obtained. ARP is a mechanism for resolving MAC addresses. After obtaining the next hop IP address by routing, resolve the MAC address. This is for communicating with the other party via Ethernet. How ARP works is very simple. First, who has this IP address? And send a request. This broadcasts the destination MAC address with all 1 bit so that all terminals on the network can receive it. When I see that my IP address is claimed, I have it. And reply. If it is not your own IP address, ignore the request and do not reply. This will resolve the MAC address. Each terminal retains an ARP table that shows the relationship between the resolved IP address and MAC address for a while. This ARP table can be checked by any terminal. It can be displayed by the ARP command even on Windows. Finally, I would like to summarize briefly. This is a summary of transmission processing in an Ethernet terminal. Terminals perform the same operations, including not only computers and smartphones, but also routers. Also, this time, we have understood the processing from when the destination IP address is determined to when the packet is sent, so this is a summary of the contents. First, it finds the corresponding network address from the routing table and determines the communication destination. Next, the MAC address is acquired from the destination IP address by ARP. Finally, the flow is to add an Ethernet header, construct the data, and send it. That's all for IP address and communication mechanism this time.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.